Okay, let's correct this test. Yours might be in a different order. I'm not sure, but you'll just have to find the one that I'm on in your test if it is in a different order. All right, number 1 says, which ordered pair is the solution to this system of equations? If you'll remember, we learned how to do this on the calculator. I have 2 equations, so I'm going to use menu 3, 2. This pops up. I have 2 equations. My variables are x, y, so I'm going to say OK. And I'm going to type in these 2 equations. In the top box, I'm going to type in y equals 2x minus 3. And then in the bottom box, I'm going to type in y equals 7 minus 0.5x. It's already defined my variables, x and y, so if I hit enter, I get 4, 5. So this is my answer, but for corrections purposes, let's do this. Let's prove that this is the point. This is my x value, this is my y value. So that means if I plug x and y into each of these equations, I should get 2 true statements. So here, 5 equals 2 times 4 minus 3. Does everybody see what I did? I put 4 in where the x is and 5 in where the y is. Is this a true statement? Well, I could type it into my calculator. 5 equals 2 times 4 minus 3. True. Yes? 8 minus 3 is indeed 5. Let's plug it into this equation. 5 equals 7 minus 0.5 times 4. Half of 4 is 2. 7 minus 2 is indeed 5. If you wanted to double check on your calculator, you would simply say 5 equals 7 minus 0.5 times 4, and it tells you it's true. Okay? Both of those are true. Number 2. Which statement about the graph is false? So we've got this one. The graph is proportional. Well, it's going through 0, 0, so that is true. It passes through 0, 0. The graph is non-proportional. This is false, right? It can't be proportional and non-proportional. Okay, so this is the one that is false, but let's just show that we understand everything else. The graph has an x-intercept and a y-intercept. True, right? It goes through the x-axis at the 0, and it goes through the y-axis at the 0. Okay, and this one, the graph has a constant rate of change. That's true. If it's linear, it has a constant rate of change. That's what's making it linear. Okay? Number 3, review the table and identify the y-intercept. This is so easy. Okay? 0's partner. You might have heard us refer to it as that. It's when x equals 0. When x equals 0, what is his partner? Okay? Number 4. Which line has a slope of 5 over 2? The first thing that I notice is that this is positive. So that means that the line has to be going up like that. So I'm going to get rid of line A and line B because both of those lines, as you can see, are going down the graph. So A is out and B is out. It's either C or D. So I've got to figure out the rise over the run. right? So we'll do line C first. Line C goes through this point, and it goes through this point. So if I do my rise over my run, I've got 1, 2, 3, 4, 5 over 2. And that's what I'm looking for. So that would be line C. But we'll just double check. It's always a good test taking strategy to double check. For line D, it goes up 2 and over 1, 2, 3. 2 over 3. C is the one. Okay? Number 5. Review the table and identify the slope. Okay, slope is the change in y over the change in x. So I got to figure out how much this thing is changing. If I go from -4 to -6, I'm going down 2 units. Down 2 units. Down 2 units. Down 2 units. On the x side of the table, I'm going up 2 units. So my change in y is -2. My change in x is 2. And -2 divided by 2 is -1. Number 6, what is the slope of the following graph? Remember, they've given me a graph, so I'm always going to refer to rise over run when they give me a graph. I'm going to do from point to point, I'm going to go up 1, 2, 3, and over 1. 3 over 1, which equals 3. I'm just going to double check on that bigger triangle, just make sure I'm right. This goes up 1, 2, 3, 4, 5, 6, oops. 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1, 2, 3. 9 over 3 still equals 3. Just a little strategy to double check and make sure that I'm not making a mistake. Number 7. Which equation is an example of a direct variation? This right here is just another word for proportional. So that means that my equation should look like this. Nothing added or subtracted at the back. So when I look at my answer choices, should be y equals, nope. Okay, y equals, oh, but it's got that thing at the back, so no. Y equals, nothing should be added or subtracted at the back. So here it is. Y equals 4x, where my k would equal 4. Alright. Number 8. Which statement compares the data on these graphs? So we've got 2 graphs. Let's see what my statements say. It says both have the same y value for x equals 2. Alright, here, when x equals 2, y equals 6. Here, when x equals 2, y equals 3. This was at 3, this was at 6, so nope. Okay. This next one says m is linear, so if you connect these, you'd make a straight line. That's true. And n is nonlinear. That's true as well. Looks like this is my answer, but let's double check. Both show proportional relationships. Nope. That's out because they don't, the first one, how do I want to say this? Graph, mark that out. Graph, good grief. Graph M doesn't go through 0, 0, and graph N can't be proportional because looks like it might go through 0, 0, but guess what? It's not linear. In order to be proportional, you have to be linear. Okay? And says M is increasing, N is decreasing. They're both increasing. They're both showing a general increase up the graph. So that one is not true because this part right here is not true. Okay? Number 9. Review the table and identify the unit rate. Unit rate. This is the slope when it is proportional. So in that case, we could do y divided by x. So here we go. 4 divided by 1 equals 4. 8 divided by 2 equals 4. 12 divided by 3 equals 4. 16 divided by 4 equals 4. So my unit rate is 4. Which answer choice shows that? 4 inches per hour. 4 inches on top per hour on bottom. Y over x. Okay? Number 10. It says identify the y-intercept. I love these. Zero's partner, right? Zero's partner. It's when x equals 0. Easy breezy. Number 11. This graph shows a bicyclist moving at a constant rate. What is the relationship? My choices are either proportional or non-proportional. This thing is going through the origin. That makes it proportional. It goes through 0, 0. Number 12. What is the equation for line D? First thing I'm going to do for line D is highlight that line. Kind of hard to see. So there's line D. The first thing I notice about line D is that the slope is negative. So the coefficient of x has to be negative. This looks a little tricky because it doesn't look like the way we normally write our equations. They actually put the x in the back and the y-intercept in the front. So they were trying to be a little tricky. So remember, your slope here is -1, and your slope here is -1. Okay? I'm going to get rid of this one because that's a positive slope. Same here. This is a positive slope. So these are out. See, it's one of these two. Okay? This one, okay, the slope is -1 for both. This one is starting at 60, and this one is starting at 10. When I look at where this thing starts, looks like these are going by tens. 10, 20, 30, 40, 50, 60. This is the one. It starts at 60. All right. Number 13. What is the equation of the following graph? So I see this line right here. It's a horizontal line. That means it has 0 slope, right? I also notice that it is touching the y-axis at the -1. So it doesn't touch the x-axis at all. So all of these x equals are out. It can't be x equals anything. Oops, sorry. Can't be x equals anything. It's got to be either y equals 1 or, ooh, you know what? I think there's a typo on this one. I think this should say y equals -1, because y equals 4 would be up here somewhere. So it's not this one. I think there's a typo here. This should actually say y equals -4, and this would be your answer. All right, number 14, name the constant of variation, the k, right? Remember, y equals kx. So you're looking for the number that is in this spot, right? What number is sitting in front of x? Well, y equals -2/9 x. Hey, -2/9 is sitting in front of x. So this is my answer. K would equal -2/9. 15. What is the slope of the line? Alright, so this is going through the origin. So I could use these little boxes here. Since it's going through the origin, I can use these boxes to figure out the slope, right? And it's y over x, since it's proportional. So here I've got 60 over 2, which equals 30. Alright, you could double check yourself, do another box just to make sure. That next box is 120 over 4, which also equals 30. For good measure, I could do the next box, which is 180 over 6, which, hey, guess what, equals 30. Alright. Number 16. The equation y equals 4.7x represents the rate in miles per hour at which Melissa walks, and Kelly walks at a rate of y equals 5.7x. So who walks at a faster rate? Alright, this equation, that's 4.7 miles per hour. Right? This one is 5.7 miles per hour. Well, y'all, which is faster, 4.7 miles per hour or 5.7 miles per hour? 5.7 miles per hour is faster. That is Kelly. Number 17, which graph shows a proportional relationship, which means that it passes through 0, 0, passes through the origin. I see one line that is touching that origin, and it is this line right here, and that is line B. Number 18, which line has a slope of -2? Negative slope. So that means that the line has to be going down like this. Yeah? So the ones that are going down are right here. This line is going down, and this line is going down. Lines C and D are out because they are going up the graph. Alright, and we need a slope of -2. So I'm going to look at line B first. I see a clean point right there and a clean point right there. And if I go from point to point, I have to go down 2 and over 1. Down 2 and over 1. That is negative 2 over 1, which does indeed equal negative 2. That is line B. But we'll just double check line A. If I'm going from point to point on line A, looks like it's very hard for me to see. I think clean point, clean point, clean point, down 1 over 2, down 1 over 2. It's backwards. Is the slope of line A. But that one's out. Okay. 19. Which equation shows the proportional relationship in the table? So it's already telling me it's proportional. So that means I can rely on y over x. So that means 130 over 2, which equals 65. So this is my k. Right? Y equals kx. So you plug in 65 right there. And you could double check yourself and just make sure that 325 divided by 5 does equal 65. I'm going to get a calculator out for that one. All I'm doing is double checking myself, making sure I haven't made some sort of numerical error. Control divide. Yep, equals 65. Right, and this one's easy. 650 divided by 10 is 65. So, okay. All right, and the last one. What is the equation of the following graph? So I see this line, and I see that it is not touching the y-axis at all. Doesn't touch the y-axis at all. So y equals something will not work. So I'm going to get rid of my y equals. Okay, so it's one of these, x equals 5 or x equals 2. So where does this thing cross the y-axis? X-axis. It crosses right there. It crosses the x-axis at the 2. X equals 2. At every single point on this line, the x value is 2. Okay, this point right here that they gave us, the x value is 2. And the y value is 1. This point right here that they gave us, the x value is 2, and the y value is 1, 2, 3, 4, negative 4. But every single point on this line, your x value is going to equal 2. That's why it's x equals 2. And that is it.